And good day, pre-algebra. On to Unit 3 we go, and we start with CO13, which is interpreting and writing numeric and algebraic expressions. That's a lot of words there. Interpreting, writing, numeric, algebraic. This is going to be kind of a wordy objective in the sense that we're going to define a lot of things. This is going to help you with word problems going forward, because the whole knock against word problems is that there's no equation set up for you, right? You kind of have to write it yourself, and then you have to solve it. You have to pick out which operations you're using and everything like that. So what this one's designed to do is to kind of tell you what are some words or phrases that mean the main four operations, so that when you see them, you know what's going on, because that's half the battle with these word problems. But we'll start by defining an expression. An expression is simply a mathematical statement. Is my pen working today? Hold on. Technical difficulties. Well, no. We'll see what's okay. Okay. We can fix this. This will be good. There we go. See, that was some algebra jotting too. All right, let's try this again. An expression is, there it is, a mathematical statement. Okay. And the important thing to remember here is an expression does not have an equal sign. Okay. It's simply an expression. 2 plus 3 is an expression. 2 plus 3 equals 5 is an equation. Okay. You can't have an equation without an equal sign. An expression does not have one. And so there you go. A variable. What's a variable? I know you've talked about variables before, but how would you define it? Variable. You are very able to define this. Really? That helped? Oh, okay. Haley? Okay. So it is usually a letter. It really could be anything, you know, it could be a symbol, it could be a rock, I don't know, but it's usually a letter that represents an unknown value. Okay, it's a letter, usually, for our purposes, that represents an unknown value. Pretty soon we're going to be solving for the variables once we start to work with the equations, but there are things that you can kind of, when you've done like science experiments, you know, that variable is what you're testing. You plug in different things, right? Did you do that whole bean plant experiment? You were in like first grade or second grade where you have like a plant sectioned off into 4 areas, and one section gets like good soil, the other section gets more frequent water or something like that. You change something about what's happening, and you can make decisions on what works best or whatever else. Okay, anyway. Moving on down to the table here, which is a key point, so this can go on a help sheet for the test. What are some words or phrases that mean the main 4 operations? And again, this is going to help you with word problems later on. So what can you tell me? What are some words or phrases that mean these 4 operations? Cade? Sum, for which one? Addition. When you see the word sum, it means you are adding. John? Difference, for which one? Subtraction. Okay, and I'm going to leave the next 3 for subtraction open because I want to talk about 3 specifically. So no more for subtraction. Difference is good. Let's go to the other 3. Sophie? Product for multiplication. Good. Haley? Quotient for division. Excellent. Others? Cade? For which one? So typically not. The word groups actually can apply to 2 of them, but it depends on what else is with it. Okay. For multiplication, if you have the phrase groups of, 6 groups of 8, would be 48, 6 times 8. We've talked about that word of meaning multiplication before. Groups of would mean multiplication. How can you say division using the word groups? Anyone know? Blake, sit flat, please. If you have the word into groups, you are putting 48 objects into groups of 8. You'll have 6 groups in all, 48 divided by 8. That would mean division. So groups can be a little bit tricky. You have to look at what else is around it. Groups of, multiplying, putting into groups, dividing. Sophie? Yes, times for multiplication. Good. Abby? Yes, we talked about the words, I'll put 3 of them. Per, each, every. Those 3 typically mean that you're going to multiply. Good. Cade, some more. Plus for addition. And obviously minus would be the one for subtraction, but we're going to leave that one open for other things. Blake? For? Yes. Good. I kind of already have that one for you. Plus is there. Cade? Would add be one for addition? Added to would probably be how you'd see it. But we're going to go with more than. Would be probably more common. Okay. The other word for addition would be total. Right? When you go to the store and you buy all your stuff and the cashier rings it all up and it says your total, right? All the prices have been added together. How about division? Let's go back to division a little bit. Other words, phrases for division. Yeah. Divided by, put that in there. Okay. And then probably the most common two would be half or fourth, right? Half would be dividing by 2. Fourth would be divided by 4. Third, would obviously be part of it, but it's not quite as common. Fifth is dividing by 5, etc. Okay. But the trickiest one of all of these is subtraction. Okay. And I'm going to put 3 phrases up here, and I want you to tell me how they're alike and how they're different. We have subtracted by. We have subtracted from. And we have less than. Subtracted by, subtracted from, and less than. Okay? With addition, does order matter? Is 3 plus 2 the same thing as 2 plus 3? Yeah. Yes, both equal 5. With subtraction, order is very important. Okay? If I ask you for the difference of 20 and 12, what's that asking you to do? The difference of 20 and 12. The difference of 20 and 12. Camille? Nope. The difference of 20, oh, my red's in timeout. The difference of 20 and 12. Cade? Essentially 20 minus 12. Okay? If I say 20 subtracted by 12, what order is that? 20 subtracted by 12. Sophie? 20 minus 12? What do you mean? If I said 20 subtracted by 12, is that 20 minus 12 or 12 minus 20? Which one comes first? Lexi? 20 minus 12 again. Okay? 20 subtracted by 12, or the difference of 20 and 12 would both have the 20 coming first. Okay? The other two, the order is going to switch. 20 subtracted from 12 means you're starting with 12 and you're subtracting 20 from that. That one's going to be 12 minus 20. Even though we read it 20 subtracted from 12, the 20 is written first. In the expression, it's going to be 12 minus 20. Same thing for if we have 20 less than 12. 20 less than 12, again, that 20 is written first, it's read first, but 20 less than 12 is going to be 12 minus 20 also, which those two things are different answers, right? 20 minus 12 is positive 8, 12 minus 20 is negative 8. So you've got to be very, very careful, particularly with these two in the middle, right? Subtracted by or subtracted from, are going to mean different things, okay? So when you see these phrases in the expressions below, make sure you're looking up to see, even though, if we have, like I said, 20 subtracted from 12, that 12 is actually written first. Okay? You need me?
I'm going to put that on your desk.
Oh. Okay. Questions on that? Again, that can be pretty tricky. Okay? Especially since for other operations, order doesn't matter. Addition and multiplication versus subtraction, it does. All right, let's look at down below here. The sum of 9 and 7. It says write the verbal phrase as an expression or write the expression as a verbal phrase. Here we're given a verbal phrase and we want to write the expression. What is the sum of 9 and 7? Dayton. It equals 16, but is it addition, subtraction, multiplication, division? Addition. 9 plus 7. Okay. You could also write this 7 plus 9 if you wanted to, because again, for addition, that order doesn't matter. Okay. How about the difference of a number and 9? If it says a number, that's a variable, right? We don't know what that number is, so we can plug in a letter, any letter you want. Could be N, could be X, Y, A, B, C, D, whatever you wanted to. Okay. But the difference of a number and 9, how's that going to be written? The difference of a number and 9. Jeffrey? N minus 9. Right? Difference means subtraction. The difference of a number and 9 be N minus 9. Could we reverse this one to put 9 minus N? No. It would not be correct in this case because for subtraction, the order matters. For addition, it does not. Sir?
For the answer, can you just put addition or you have to do the...
You have to write this out. Okay? Because just the word addition isn't an expression, right? N minus 9, that mathematical statement, that's your expression. The product of 3 and 6, what's that going to look like? The product of, somebody haven't heard from me yet today. Let's get a new voice. The product of 3 and 6. Quentin. 3 times 6. Could we reverse that? 6 times 3 would also work. Good. Okay. 18 groups. Question?
Yeah. Do we have to write it?
No, you don't have to write them both. You just need one of them. 18 groups of a number. Groups of. Kendall. Good. 18 times n. Again, we have that a number there, so it's any variable that you want to. Okay. You can write 18n. You don't need the multiplication symbol when you've got a number followed by a variable. If you reverse that, though, which you can because you're multiplying, you wouldn't write n18. If you reverse it with the variable first, you'd have to put the multiplication symbol in there. So it's more common to see it written like this, just because mathematicians are lazy people. And the multiplication symbol is just extra work. So you see it more commonly like that. Cade. The next one, 18 less than 12. Cade? 12 minus 18. Here's that example of that phrase less than. Okay, which if you look up above, it means that order is going to be reversed. 18 less than 12 means you're starting with 12 and taking 18 less than that. So it's going to be 12 minus 18. Okay, you might want to star this one on your page or underline it like a red flag. I guarantee this is going to show up on your test, that phrase. And what I'm looking for is whether or not you know to switch the order the way it's written. right? 18 less than 12 is actually 12 minus 18. Which other one on this page is going to have the order reversed? There's one more that's going to have the order reversed. Camille? Sophie? Good. Your other red flag is this one here. And it's because of that phrase, subtracted from. Okay? That word from, subtracted from, means the order it's presented is going to be flipped. So, some of these are going to be a little bit more multi-step. 3 times a number plus 8. How is that different from the next one? You've got 3 times a number plus 8, and then 3 times a number plus 8. The only difference is where the comma is. But how does that change things, do you think? Cade?
Because you would do 3 times a number, and then the answer to that plus 8.
In the first one, right? What that comma does is it kind of separates the operations. 3 times a number, that's being done first because of that comma. Then you're adding 8, right? That's like your second step. So how you might write that, 3 times a number might be just 3n and then plus 8. Because order of operations says you're going to have to multiply 3 and n first, right? That second one, in this case, the 3 and the times a number plus 8, they're separate. So what are you going to need in that second one there that you didn't need in the first one? Because now this is saying that times a number plus 8, that number plus 8 is together. Sophie? Good. Parentheses, right? We still have all the same pieces, but the difference is in that second one, that 3 is separate from the n plus 8. Okay? So notice the difference here. 3 times a number, that's together. That's 3 times n. Then we add 8. Order of operations says we multiply first anyway, so we don't need parentheses. But in 3, comma, times a number plus 8, that number plus 8 is together. And because that goes against the order of operations, we would need parentheses here. Right? Your job is to do the ones that we didn't do here. And then the 3 on the bottom here has you write the verbal phrase. So for x plus 5, you could write x plus 5. The total of x and 5. X more than 5. 5 more than x. Right? The sum of x and 5. All those different words that we used up in the chart above can be used here. Abby?
I said like a number plus 5.
Sure. Great. Okay. This next one is similar to the one we just talked about up above. You've got those parentheses around the 2 plus n. So take a look at where that comma was in the example with parentheses up above, okay, and kind of apply that to this here. And then the third one, you've got a fraction, which of course we know is the operation of division. So folks, number game tomorrow. Please, I'm begging you, we can do this. You have how much time to work on your homework now?
2 seconds.
No,
20 minutes.
like almost 20 minutes to work on your homework. And we did almost all of it. If you finish, check your neighbor, make sure your neighbor finished as well, or is at least working on it. Okay? If we don't play the number game tomorrow, this will be the biggest disappointment in the human race. That might be an exaggeration, but let's get our homework done. Okay? All right, folks, that's how you math.